Introducing the Big One. Just another day at the beach when it comes to fractions. I'm your host, Mr. Winlowski. Now before we begin, I need to give you a little background knowledge involving fractions. Actually, this one goes for everything. Multiplying anything by 1 equals itself. 17 times 1 equals 17. 8 times 1 equals 8. 3/4 times 1 equals 3/4. An elephant times 1 equals an elephant. Anything multiplied by 1 equals itself. The value does not change. Similarly, dividing any number by itself equals 1. 4 divided by 4 equals 1. 6 divided by 6 equals 1. 1/2 divided by 1/2 equals 1. Any number divided by itself equals 1. This is important information to know as we get into what the Big One is and what it does. How do we use the Big One? Well, let's say you're given a fraction, 2/3 for example. You want to get that denominator to equal 15, but you don't want to change the value. Well, if you don't want to change the value, you've got to multiply it by 1, because as we just saw in that last slide, multiplying by 1 still equals the number itself, so the value will still be 2/3. However, if I leave it just as 2/3, I can't get the denominator to 15. So what can I multiply 3 by that will get me to 15? Oh, I'm going to multiply by 5. But also from the last slide, we saw any number divided by itself equals 1. So I'm going to make a fraction in my Big One and put 5 over 5 because that equals 1, and so I do not change the value. Now I'm just going to multiply across. So 2 times 5 up there at the numerator is 10. 3 times 5 for the denominator equals 15. So I have my new fraction. The same value as my original. 2/3 and 10/15 are the same value. They're just represented differently. Did you know? Fractions can only talk to each other if you are multiplying, or if they have a common denominator. So every time you begin to ask yourself, can these two fractions talk to each other? You have to look and say, are you multiplying the fractions? If you are, just go ahead and multiply. But if you're not multiplying the fractions, you need to look at the denominators. Do these fractions have a common denominator? If so, then you're all set. They can talk to each other. But if they don't have a common denominator, then you need to find a common denominator by using the Big One like we just did there with 2/3 to get it to equal 10/15. And now we are going to find equivalent fractions using some examples. Please click on the picture to choose which video you would like to watch. The top one is all about lists. The middle one will show you the ladder method. And the bottom picture will show you the jump clap guys method. Alright, you chose the list method. Now I'm looking at these two fractions and I'm trying to figure out, can these two fractions talk? Well, I'm not multiplying them, so that's off the list. And they don't have common denominators, so that doesn't work. So what I've got to do is multiply by the Big One. So I make a Big One for each of these, like so. And now I need to find a common denominator for my fractions. So I'm going to start listing off the multiples of 5 because that's my first denominator. First 5 are usually appropriate, so I go 5, 10, 15, 20, 25. Now I've got to do the same thing for my second fraction, so I list out the multiples of 7. And I've got 7 up to 35, I've got 5 up to 25, but I don't have a common denominator yet. So I'm going to have to add a few more to my 5 to get up there, because I've already got 7 up to 35, so it's got a higher number there at the end. So I had 30 and 35, and bingo! There's my least common multiple. Now how many times does it take 5 to get up to 35? Well, I can just count off. 1, 2, 3, 4, 5, 6, 7. 7 times. So I'm going to put 7 over 7 in the big one, because as you remember, dividing a number by itself still equals 1, so it does not change the value. Now I just multiply across. 3 times 7 is 21, and 5 times 7 is 35. Now I'm going to do the same thing to that second fraction. 1, 2, 3, 4, 5. I'm going to multiply inside the big one by 5 over 5. And I get 5 times 4 is 20. 5 times 7, 35. We have common denominators, so these two fractions can talk. That's how you do big one using lists. Alright, you chose to use the ladder method. Excellent choice. Now I'm looking at these two fractions here. I've got 3/5 and I've got 4/7. Can they talk to each other? Well, am I multiplying them? No, so that doesn't work. Do they have common denominators? No, so that doesn't work either. So I've got to multiply by the big one to get common denominators. So I'm going to set it up. My two denominators are 5 and 7. And I'm going to just use the ladder method here. Well, what can I take out of both? It looks to just be 1. So I'm going to take the 1 out. 5 and 7 are left. Now I'm just going to multiply all of those together. 1 times 5 times 7 equals 35. So now I need to get my denominators to both be 35. Well, what am I going to multiply 5 by to get to 35? It's going to be multiplied by 7. And as we remember before, dividing any number by itself equals 1. So I'm going to multiply the bottom and the top both by 7. What I do to the bottom, I've got to do to the top. And on the other side, I'm going to have to multiply by 5, because 7 times 5 gets me to 35. Now on the top, 7 times 3, 21. For the second fraction, that numerator, 4 times 5, equals 20. Now I've got common denominators, so now these two fractions can talk to each other. That's how you find common denominators using the big one with the ladder method. Good choice. I love Jump Clap Guy's method. So I'm looking at two fractions here. I've got 3/5 and I've got 4/7. Can these two fractions talk to each other? First thing we look at is, are we multiplying these two fractions? Nope. Well, do they have the same common denominator? 5 and 7, nope. Alright, so what I need to do is multiply by the big one in order to get a common denominator, because these two fractions need to talk to each other. So I'm going to set up my two denominators. I've got 5 and I've got 7. Now I've got to find the prime factorization of both. Well, 5's prime and 7's prime. That's pretty easy. So I've got 5 to the first, and I've got 7 to the first. Line them up. 7 to the 0, and I've got no 5's there. Circle the biggest one because I'm looking for LCM. So I got 5 times 7, and 5 times 7 will give me 35. So I've got 35 as my common denominator. Now I need to look at this first fraction and see 5 times what gives me 35. Oh, I know that. That's 7. So I'm going to multiply both the top and the bottom by 7, because if you remember, what you do to the bottom you do to the top. If I divide a fraction, or if I divide a number by itself, it equals 1. The value does not change. Similarly, I want to do the same thing on the other side. 7 times 5 is 35. So now I'm multiplying my numerators together. 3 times 7 is 21. 4 times 5 is 20. Now these two fractions have a common denominator, so now these two fractions can talk to each other. And that's how you use the big 1 to find common denominators using Jump Clap Guy's method.